So what is this dummy row and dummy column? So dummy row and dummy column is a graphical method, simplex method, BACHELOR method, two-phase method and duality also. When your supply and demand value is not equal, then we can call it is a unbalanced transportation problem. For transporting from source to destination, the total transportation cost should be minimum in transportation problem. Simplex method is different and transportation method is different in linear programming problem. Hello everyone, I am Shweta, Computer Science Faculty, Vidhyaashram First Grade College, MYSURU. So today I will start the third unit in Operation Research Transportation Problem. So today I will explain the concept of transportation method. So what is the meaning of this transportation problem? So usually in LPP we have studied different methods. Graphical method, simplex method, BACHELOR method, two-phase method and duality also. And transportation problem is also a special type of linear programming problem. Distributing a product from a number of sources to a number of destinations. Because of its special structure, the usual simplex method is not suitable for solving transportation problem. And for transport various quantities of a single homogeneous commodity to different destinations from source to destinations in such a way that total transportation cost is minimum. For transporting from source to destination, the total transportation cost should be minimum in transportation problem. In order to reduce the transportation cost, we can use this method. And transportation problem is a special kind of linear programming problem. So, LPP stands for linear programming problem and this transportation is a special type of LPP in which goods are transported from set of sources. So, here I have a sources. I need to send all the sources goods from source to destination. I have to transport all the goods from source to destination, but the transportation cost should be minimum. So, in order to find the minimum transportation cost, we can apply some other methods in transportation problem. So, transportation problem is a special kind of LPP in which goods are transported from set of sources to a set of destinations. So, set of sources to set of destinations, the transportation cost should be minimum and subject to the supply and demand of the sources and destination respectively. So, here we are using supply and demand of the sources and destinations respectively such that the total cost of transportation is minimized and it is also sometimes called as Hitchcock problem. So, transportation problem is a special type of linear programming problem. The usual simplex method is not suitable for this transportation problem because simplex method is different and transportation method is different in linear programming problem. In transportation also we are finding the initial basic feasible solution and also we are finding the optimal solution. So, in transportation problem we have to pick the minimum cost. And in transportation, we have two methods, that is finding the initial basic feasible solution and finding optimization. So, in transportation, we are finding the initial basic feasible solution and also we can find the optimization in transportation. What is the goal of this transportation method? So, it helps to reduce the transportation cost from source to destination. And in transportation, we have two types, that is balanced transportation and unbalanced transportation. So, what is the meaning of this balanced and unbalanced transportation? So, balanced means When both supplies and demands are equal, then the problem is said to be balanced transportation problem. So, for selling the goods from source to destination, we have to apply the supply and demand for that. If your supply and demand value is equal, then we can call it as it is a balanced transportation problem. So, how to find the supply and demand value? So, this is your structure of transportation problem. So, here you have a destinations D1, D2, D3 and D4 is called as destinations, and S1, S2, S3 is called as sources, and we have destinations. Sources is S1, S2, S3, D1, D2, D3, D4 are the destinations. So, here, so what is the goal of this transportation? We have to reduce the transportation cost. We have to minimize the transportation cost. So, example, if you have a company, you are manufacturing a product. Example, you assume that you have one small company, you are manufacturing so many products. So, if you are selling the products from source to destination, you have to pick the best selection called the minimum transportation cost, right? So, for finding the minimum transportation cost, we can apply so many methods that I will explain later. So, transportation means, the goal of this transportation means we have to reduce the minimum cost. We have to reduce the total transportation cost. We have a sources and destinations products details here, supply and demand. Here you just check this. For supply we have 7 units, 9 units and 18 units. And in demand 5 units, 8 units, 7 units, 14 units. In this structure, how many sources are there? How many destinations are there? So, sources means it is a row, destination is column. So, M plus N minus 1. So, M plus N minus 1 means we can find the number of rows and columns. Here, I have 3 rows, 3 plus 4 columns. 3 plus 4 is 7. 7 minus 1 is 6. So, next, what is the meaning of this balanced transportation problem? For finding balanced or not, we have to add all the supplies and we have to add all the demand value. So, you can understand it is transportation, then you can understand is this balanced transportation or not. Example, I have 7 plus 9, 7 plus 9 is 16, 16 plus 18 is 34, 34 units. And add all the demand values. 5 plus 8 is 13, 13 plus 7, 20, 20 plus 14 is 34. So, in supply also I got 34 and in demand also I got 34. So, it is balanced. When your supply is equal to demand, supply value is equal to demand value, then we can call it as it is a balanced transportation problem. When you are solving the transportation problem, sometimes you will get balanced transportation problem or sometimes you will get unbalanced transportation problem. So, if you get balanced transportation problem, how to find the total minimum cost? I will explain it later with an example. And if you get any unbalanced transportation problem, what you should do is, you have two types in transportation. One is balanced and second one is unbalanced. If you get unbalanced transportation, when the supply and demand are not equal, then it is said to be an unbalanced. When your supply and demand value is not equal, then we can call it is a unbalanced transportation problem. In this type of problem, so here you just calculate the supply value and demand value. Add all the supply values. 70 plus 55, it is 125. 125 plus 100, 225. And add all the demand values. 85 plus 35, it is 125. 85 plus 35 plus 50 plus 45, it is 215. Now you can cross verify the supply value and demand value. In supply, you got 225 units. In demand, you got 215. So here, supply is not equal to demand. So it is unbalanced. When supply is not equal to demand value, then we can call it as it is an unbalanced transportation problem. Supply is not equal to demand value. It is not equal, it is unbalanced transportation problem. If we get unbalanced transportation problem, what we can do for finding the minimum transportation cost? Here, listen carefully. In this type of problem, either a dummy row or a dummy column, is added according to the requirement to make it a balanced problem. So, if you get unbalanced problem, you have to add a dummy row or either it is a dummy column. You can add according to the requirement to make it as a balanced. So, for make it balanced, you have to apply a dummy row or dummy column. So, what is this dummy row and dummy column? So, dummy row and dummy column is an extra row. For make it balanced, we have to add one extra row or it can be extra column for make it a balanced. So, how to add the dummy row and dummy column? Here, the supply value is greater than the demand value. Is it right? Supply value is greater than the demand value. Supply value is 225 is greater than the demand value is 215. If supply value is greater than demand value means here 225 minus 215 means it is 10. Right? So, 10 units is difference in compared to demand and supply. So, where you got less value in demand, you got less value than supply value. So, it is in the row, right? So, you have to add the column. So, here I will add one extra column for make it balanced. In demand, I got less value. So, demand is 215, supply is 225. Supply is greater than demand value. So, demand value is in the row side. So, I need to add one column, dummy column. So, I will add 0, 0, 0. So, all the values are 0, but in demand place, you have to add one extra 10 units because so 10 number is shortage in demand value. So, I have to add one extra column. So, this is called as dummy column. One row or it can be a column, dummy row or it can be a dummy column. You have to add for make it balanced. Clear? If you get any, if your demand is greater than supply, you have to add one extra dummy row, not column. If your supply value is lesser than the demand value, you have to add one dummy row. So, here in this place, you can add one dummy row. So, how many value is required for make it balanced? You can add in dummy row. So, that is called as D is greater than S or D is less than S. So, this is called as unbalanced transportation problem. So, unbalanced means when your supply value is not equal to demand value, then we can call it as it is an unbalanced transportation problem. And if your supply value is equal to demand value, we can call it as it is a balanced transportation problem. When you are solving the transportation problem, sometimes you will get balanced or sometimes you will get unbalanced. So, if it is unbalanced means you have to make it as balanced for adding dummy row and dummy column. So, this is the main concepts of transportation problem. And so, already I have explained this. Demand is greater than supply. Add dummy column in a matrix with zero cost. Matrix with zero cost. Dummy column means matrix with 0 cost, and how many value you need to add, that you can add it in this place, demand place. And if your supply is greater than demand, add dummy row in a matrix with 0 cost. So here you need to add one dummy row in a matrix 0 value. So it is 0, 0. So how many value you have to add? That many value you can add it in a row. So this is called as dummy row and dummy column. You can expect this question for 2 marks. So what is dummy row and what is dummy column? And the next topic is methods can be applied only if it is balanced or else dummy row or dummy column. So when you are solving the transportation problem, sometimes you will get balanced or sometimes you will get unbalanced. So if you get unbalanced or if you get balanced, so we have some main method in transportation problem. They are very important concept in transportation problem to find the initial basic feasible solution. There are 3 methods, that is northwest corner cell method and least cost cell method and Vogel's approximation method, BAM. I'll repeat. First method is northwest corner method for finding the initial basic feasible solution. We have 3 methods in transportation problem. You can expect any 2 questions on this topic. Definitely there will be a problem on these topics. So you can expect northwest or least cost or Vogel's method. You can expect 2 methods on this topic. So easiest topic in your syllabus is northwest, least cost and Vogel's approximation. So here for finding the initial basic feasible solution, we have 3 methods in transportation problem. They are northwest corner method, least cost method and BAM. BAM stands for Vogel's approximation method. So these are the methods for finding the initial basic feasible solution in transportation problem. So first method is northwest corner method. The name itself indicate it is northwest corner method, north side. I will explain it with an example. So what is the definition of northwest corner method? The northwest corner rule is a method adopted to compute the initial feasible solution. So what is the role of this transportation problem? For finding the lowest minimum cost. So what is the role of this transportation problem? For finding the minimum transportation cost. In transportation, we have 3 methods, northwest, least cost and Vogel's approximation. In both the methods, we can find the initial basic feasible solution in transportation problem. In northwest corner method, the basic variable we are selecting in the north side. So that means the corner value. The corner value in the sense the basic variables which we are selecting in the left side, that is left corner value. So this is I am selecting for finding the initial basic feasible solution. So this is my north corner value. So north corner value is left corner value. In northwest corner method, I am selecting this is my basic variable for finding the initial basic feasible solution. So this is the first step in your north corner method. So in north corner method, the basic variable you are selecting from the extreme left corner. In left corner, I am selecting the basic variable in northwest corner method. And what are the steps for finding the initial basic feasible solution in northwest corner method? To find an initial basic feasible solution, we have to follow some steps. Step 1. Select a northwest corner cell of the transportation tabular. That means left uppermost. Left uppermost. You have to select for finding the basic feasible solution. This is your north corner cell, left corner cell. And subtract this value from supply and demand. So you will get supply here and here you will get demand value. You just observe this supply and demand value. In supply and demand value, you have to select the minimum value out of this supply and demand value. You have to select the minimum value. So subtract this value from supply and demand of respective row and column. And if the supply is 0, if your supply value is 0, then you can cancel this entire row. If your demand value is 0, then you can cancel this entire column also. If you get 0 in your demand, you can cancel this entire column. If you get 0 in row, you can cancel this entire row also. And if the supply is 0, then cross in the sense strike that row and move down to the next cell. And if the demand is 0, then cross that column and move right to the next cell. And if supply and demand both are 0, then cross both row and column, move diagonally to the next cell. If your supply value also 0 and your demand value also 0, then move to the next corner cell. And repeat these steps until all supply and demand values are 0. Until all supply and demand values are 0, till that you have to repeat the steps. It is very easiest topic in your syllabus, northwest corner method. It is very simple concept. First step is you have to select the left corner value for finding the initial basic feasible solution. I will explain with an example for north corner method, northwest corner method. So first problem in northwest corner method. First observe this table. Here I have 4 destination value D1, D2, D3, D4 and I have source S1, S2, S3. I have demand and supply. So what is the first step? First you have to check whether it is balanced or unbalanced. If it is balanced, you can proceed, or if it is unbalanced means you have to add a dummy row or dummy column according to the requirements. And here you just observe the supply values 300, 400, 500, it is 1200. And add all the demand values 250, 350, 400, 200, it is 1200. Please add these values, supply value and demand values, so you can check whether it is balanced or unbalanced. So this problem is balanced problem. It is balanced transportation problem. I can proceed further. And what is the next step? So next step is you have to select the north corner cell. North corner cell means left corner cell. So here the north corner cell is, this is my north corner cell 3. I will select this is my north corner cell. So 3 is my north corner cell. I will select this 3. And you just observe this supply value and demand value in column 3. So first left corner value variable is 3. You just observe this column demand value and this row supply value. It is 300, supply value is 300, demand value is 250. I'll repeat, north corner cell is 3. That means left corner cell is 3. You just observe this column demand value and observe this row supply value. Out of this supply value and demand value, which is the least value? Demand value is least value. So here I will allocate 250. Because least value is demand value, I am allocating to this least corner way. I am allocating this 250 to left corner value, that is north corner value. I have allocated 250. So this cell is called as allocated cell and this is non-allocated cells. So allocated, here I have allocated 250. So demand value is lesser than the supply value. I have allocated 250. So 250 is cancelled, becomes 0. Because I have allocated 250 here, so 250 get cancelled, it is 0. If it is 0 means what we should do is, we can strike the entire column or entire row. If your demand value is 0, you can strike the column values. And supply value is 300. So 300 minus 250, it is 50. Listen carefully. Here you have to select the left corner variable. So out of this you have to select the demand value and supply value. So here demand value is lesser than the supply value. So I will allocate 250 rupees to here. So this 250 becomes 0 and entire columns will become cancelled. And here 300 minus 250, I have 50 rupees here. And so next step is select the next north corner cell. Here I have cancelled this column. So now it is my column values. This is my column. So now this is my values. Next I will select the left corner value. 1 is my left corner value. So you just check the column of 1 demand value, and so this is my north corner cell value. You just check the column value. Demand value is 350 and row value is 50. So 50 and 350, lesser value is 50. So I will cancel this 50. I will allocate it here and it will become 0. Because I have allocated 50 rupees to this north corner cell and it becomes 0. Then if it is 0 means I can strike this entire row. So 50. 350 minus 50, it is 300. Next, I have cancelled this row and I have cancelled this column also. Now, this is my variable values. So, next is select again left corner value. So, left corner value is 6. So, you just check the column of 6, it is 300 and the row of 6 is 400. 400 and 300. 300 is lesser value. I will allocate 300 rupees to this cell. So, now it becomes 0. So, if it is 0 means you can strike out this entire column also. So, 400 minus 300, it is 100. 400 minus 300 is 100. So, now I have cancelled this column also. So, now this is my variable values. Again select left corner cell. So, left corner cell is 5. So, you just observe 5 column. We have 400 in demand and row value is 100 in supply. So, supply value is lesser than demand value. Then I will allocate 100 rupees to this north corner cell. North corner cell is 5. So, lesser value is 100 out of 400. So, I will cancel this 100, it becomes 0 and I can cancel this entire row also. So, now 400 minus 100 is 300. So, next my values, so next my variables are, so next variables are only I have 2 variables 3 and 2. So, left corner cell is 3. You just observe this column value is 300, row value is 500. So, 300 is lesser value. Again, I will allocate 300 rupees to this cell. So, it will become 0. I will cancel this column also. So, 500 minus 300 is 200. So, now at last we have only one variable, that is 2. Now, you just observe this supply value and demand value. If you get last value in your table, your supply value and demand value should be same, otherwise it is wrong. So, supply value is also 200, here I have demand value also 200. So, it is perfectly correct. So, I can proceed here. So, here both the values are same. I will allocate 200 rupees to north corner cell. So, north corner cell is 2 only. I have only one variable. So, I have allocated 200 rupees. So, it will become 0, will become 0. 0 means I can cancel this variable also. So, this is the main concept of north corner. It is not completed. Still, you have to find the total minimum cost. So, for finding total minimum cost, For finding the total minimum cost, just observe the allocated cell. So, which are the allocated cells we have? 3, 250, 150, 6, 300, 500 and 3, 300, 2, 200. You just write all the allocated cell 3 into 250 plus 1 into 50 plus 6 into 300 plus 5 into 100 plus 3 into 300 plus 2 into 200. So, these are the allocated cells. You just consider all the allocated cells and add these values, you will get the total minimum cost. So, your total minimum cost is 4,400 rupees. So, this is your total minimum cost in northwest corner method. So, this is your total minimum cost. With the help of this northwest corner method, I got the total minimum cost in easiest method. It is very simple method, right? So, easily you can find the total minimum cost using northwest corner method. You just select the north corner cell every time. And if it is 0 in your demand or supply, you just cancel entire column and cancel entire row. So, you just follow the steps. So, finally, you will get the total minimum cost. So, this is about your northwest corner method for balanced problem. So, in my next session, I will continue with the next problems. Thank you.